So, this is the Indian standard for four-wheelers. So, here you see in India we had this BS1 or India 2000 we called it. This was a copy of Euro 1. This was implemented in 2000 all over the country. And then Bharat Stage 2 was a copy of Euro 2, which was implemented in NCR plus Mumbai, Kolkata and Chennai. So, all the metros, 4 metros. And then from April of 2003, it came into NCR plus 11 cities. And then from April of 2005, it was implemented nationwide. Okay, so, it gave enough time for the OEMs to match. And people, OEMs normally have a big inventory, they make like 100,000 vehicles, and suddenly you say the emission norms have changed, and then the inventory goes for a toss. What do? You have to scrap them or sell them to African countries at a discounted price. So, it is a big loss actually. So, Bharat Stage 3, this is copy of Euro 3. It was implemented in NCR plus 11 cities in April of 2005, same date when Bharat Stage 2 was implemented in the whole country, and then it was implemented nationwide in April of 2010. And then April 2010, when it was implemented, Euro 3 was implemented all over the country, NCR plus 13 cities adopted Euro 4. Then in July 15, this was implemented above plus 29 cities, mainly in Haryana, Uttar Pradesh, Maharashtra and Rajasthan. Then October of 2010, North India plus bordering states of Rajasthan. Then April 2016, Western India plus parts of Southern and East India. Then April 2017, nationwide. Why why it was so many iterations were done? So that the fuel is supplied and also the stocks are allowed to be cleared. Okay. Bharat Stage 5, which was supposed to be implemented on this date, but our OEM said, boss, we are not ready. Then what does the government do? They say, okay, do not worry, you go straight to Euro 6. So, Bharat Stage 6 is, they have promised that they will meet straightway Bharat Stage 6 nationwide in April of 2020, which is only 2.5 years away. And that's what tells you that your future is bright and you will get jobs in the automotive industry. Okay. So, if you look at the cities, these 11 cities, this is the Mumbai, Kolkata, Chennai, Kanpur also, Agra, see, and then there were 13 cities, these are the 13 cities. So, these cities plus Solapur plus Lucknow. So, we were earlier than Lucknow. Okay. So, this is as far as the four-wheeler program is concerned. Now, you see test requirement for type approval for flex fuel vehicles. So, type approval means that before they are set up into the field, what are the kind of tests that are done. So, you test for gaseous pollutants, you do free acceleration smoke test, you do durability test if opted instead of fixed deterioration factor, you do onboard diagnostics. So, for four-wheelers, if it is flex fuel biodiesel vehicle, then it was tested if the vehicle weight was less than 3,500 kilogram, then it was tested for biodiesel and diesel, and durability test is done only on the diesel and onboard diagnostic also on both. Three-wheelers, only these two tests were done for diesel and biodiesel, and durability was done only for diesel, OBD was not applicable. Four-wheelers with gross vehicle weight more than 3,500. So, these three tests were done on diesel and biodiesel, and durability is done on diesel. So, this is type approval test. It is not a really very of too much of academic interest, but if you go to automotive industry, you will hear this word type approval test all the time. So, I thought I will just introduce you to this. Emission standards for passenger cars. So, I told you in the earlier chart when was the implementation date, etc., but let us look at the numbers of how actually we have moved about. I told you some graphs also for the rest of the world. Let us look at what is happening in India. So, here you see this is gasoline vehicle, and here the norms are given 2000, BS2, BS3, 4, 5, 6. Diesel vehicle also same thing is given here. and when it is implemented, that year is also given here, that we have already discussed this. Okay. This also we have discussed for diesel and gasoline. Let us look at this. So, here you see carbon monoxide is one emission, hydrocarbon is another one, then Hc plus NOx is another one, NOx is another one, particulate matter is another one, and the most recent addition is PN. PN is particulate number. So, this is something which is a very recent addition. So, I told you that 1991 gasoline vehicles were the first one to implement to attract the emission norms. So, carbon monoxide that was allowed was 14.3 grams per kilometer, and Hc was allowed was 2 grams per kilometer, only these two norms. That was right when the first emission norms were introduced in India. 1996 when they were tightened, 8.68, so almost 50%, and this was removed, but Hc plus NOx was put at 3. 1998 this was further removed to half, 4.34, and this was also done half. Now, you can imagine 2 years suddenly you are asked to cut down it to half, so that is quite challenging. Okay. So, come BS1, so this was further reduced to half, and this was also almost half, Hc plus NOx. BS2 2005 2.2 and 0.5. BS3, come BS3 you have also talked about this norm plus Hc plus NOx. So, now you have separated Hc plus NOx, Hc is separate, NOx is separate, and everything put together this was 0.5 and this was 0.215. So, it is less than half actually. Okay. BS4 this reduced to more than half, this reduced to half, and this also reduced to half. So, BS3 to 4 is 50% everywhere across the board for gasoline. BS5 of course, it is not applicable, so we did not accept it, but look at BS6. So, BS6 there is no change in the CO, 1 gram per kilometer. Hc also no change, is very low. NOx has been reduced from 0.08 to 0.06. PM limit on the gasoline has been introduced to 0.0045, and also the particulate number for gasoline. Look at diesel, this is 1992 17.3 and 2.7, 96 you reduce it to 5 and Hc plus NOx is 2, 2000 2.72 and 0.97, and this is particulate matter 0.14 gram per kilometer. Okay. This is BS2, reduce it to less than half, anyway it is a very small number, and this reduced to 0.7, this you reduce to about half. 2010 BS3 0.64, 0.05, you see this you reduce to very low level, and BS4 0.5, 0.3, 0.25 and 0.025, and BS6. BS6 is same CO, HCCO is not a problem anyway with diesel, very small numbers. Hc plus NOx is 0.17, NOx is 0.080, so very small number, 0.5 to 0.80, and this is 0.0045, and here also particulate number is introduced. So, this is what is going to give a lot of problem and create a lot of jobs in the automotive industry. Okay, this number. Okay. So, you can imagine the kind of challenge that Indian OEMs have to face just by looking at this table, and you can also see where now you can probably appreciate what kind of technological interventions will be required to meet these numbers. Okay. And we are talking of an economy segment which contributes to more than 15% of the GDP of this country. Okay. Emission standards for 2 and 3 wheelers were effective in 1991, and since then they have been progressively become more and more tightened. Now, emission standards for 2 and 3 wheel vehicles through stage BS4 are summarized in the following table. So, you see here 2 wheelers and 3 wheeler norms are shown here. In fact, let me tell you that Indian 2 wheeler emission norms are the most tightest in the world, the most, you can be proud of that actually, that this is the most stringent emission norm for 2 wheelers applicable anywhere in the world. and we are actually a leader in two-wheeler engine technology. Okay. And you can see the numbers here, carbon monoxide, and this is grams per kilometer as well, and this is hydrocarbon. 1996 you reduce it to 4.5 from 30, 2000, and this is up to April 2010 BS3, HC plus NOx is 1. Three-wheelers almost the same number, 1.25 to 1.25. 2 and 3-wheeler diesel vehicles, very low numbers. So, this is the story up to BS3 April 2010. Then April 2010 we implemented Bharat stage 4. So, they were adopted in July of 2014, they became effective in July of 2014. So, we tightened the HC and NOx limits, then harmonization of the testing was done. So, there is something called Worldwide Harmonized Motorcycle Test Cycle, WMTC or WHTC, they were developed, and first ever evaporative emission standards were developed by India. Evaporative emission standard means when you fill the tank, whatever emissions are going out. So, the emission standards even for those were developed in India. And in BS4, what we did was we did classification of the vehicles. For example, the CC, based on the CC of the vehicle, cubic capacity of the cylinder. So, less than 50, between 50 and 150 cc, and velocity, maximum velocity of 50 kilometers an hour, or displacement more than 150 cc and vehicle speed between 50 and 100 kilometer is called class 1. Similarly, class 2-1 is more than the vehicles smaller than 150 cc and velocity between 100 and 115 kilometer, or diameter more than 150 cc with velocity less than 115 kilometers an hour. This was class 2A. Similarly, class 2-2, similarly class 3-1, and similarly class 3-2. So, these were the vehicles and the test cycles for each of them. I have not put the details, but there are different types of test cycles that were developed, and if you want you can find out them on the internet, what are these test cycles and how it is done. I just wanted to give you a feel of how it is measured. Then BS4 emission standards for two-wheeler gasoline vehicles. This was implemented in April of 2016. So, different classes are given, CO is given, HC is given, HC plus NOx is given. Okay. Similarly, Bharat stage 6, which is going to be implemented in 2020, April of 2020 for two-wheelers and three-wheelers. So, these are the emission standards both for spark ignition vehicle as well as for compression ignition vehicles, and the regulations are on carbon monoxide, hydrocarbons, non-methane hydrocarbons, okay, and then oxides of nitrogen and particulate matter. Three-wheeler vehicles, so this does not have emission norms on non-methane hydrocarbon, and spark ignition does not have on the particulates, but others have. And you see in three-wheelers, this emission norms for the particulate for the two-wheelers is only on the GDI vehicle, because the PFI vehicle does not really produce any particulates. So, this is only for GDI engine equipped two-wheeler. Heavy duty vehicles, this is for the heavy duty. These are the test protocols, EC R49, that 13 mode test that I showed you. Then this is European stationary cycle, European transient cycle, world homogenized cycle. So, all these numbers are given. This is for the heavy duty, and here also you can see that in 2020 with BS6, what is most important change is that a new regulation on the particulate number is coming. Okay. In India right now, very few facilities are available which can do particulate number. We were the first one in the country to measure the particulate number and size distribution way back in 7-8 years back, and we are still the best. This is for the diesel construction machinery, commercial vehicles. So, basically you can see the engine power output is shown here. If the power is less than 8 kilowatt, 8 and 19 kilowatt, 19 to 37, 13 to 75, 75 to 130. So, construction machinery is divided based on, is classified based on the power of the engine, and there all the dates of the implementation are given for the emission norms. Bharat stage 2 norms were implemented on these days. Bharat stage 3 norms were implemented on these days. These are the norms for carbon monoxide, hydrocarbons, NOx, okay, and then particulate matter. Okay. So, you can see that this number is a little light, this is more tighter. Similarly, in India is one country which has very stringent norms for the tractors also. So, agricultural tractors are called TRAM norms, TRAM stage 1, TRAM stage 2, TRAM stage 3 and TRAM stage 4. And when you say TRAM stage 4, these are obviously tractor norms, but tractor norms can be like, you must have seen a small two-wheeled tractor also, people can walk along with the tractor. So, that is a small 8 kilowatt engine, 2 very large tractors. So, all power and size ranges are given, and when implementation date is given and all these emission norms are given. Okay. And TRAM norms have their own driving cycle to assess these emissions as well. Okay. Similarly, locomotives, right now India, who makes the locomotive? Government. Who makes the emission norms? Government. Who gives the oil? Government. So, therefore, government has not put a bell so far in its neck. So, there are no emission norms on the locomotives as of now. They are putting bell in everybody's neck, but with lot of pressure from different quarters, including the National Green Tribunal, now the locomotive emission standards are also on the anvil. So, these are the proposed locomotive emission norms. These are based on US tier norms actually. So, ALCO types and EMD types, and these are the numbers that are being talked about. This is still proposed, not adopted. Hopefully, they will be adopted. We are also stakeholder in these norms. Similarly, gensets is a big market in India, okay, because the power supply is so unreliable that everybody has a genset in their house or commercial establishment, and these are in different sets. So, gensets are divided as less than 19 kilowatt, 19 to 50, 50 to 175, 175 to 800, and there is another category more than 800 kilowatt also. And so, for them the standards are this is 2004 or 5 standard, implementation date was in 2004, and these are the emission norms: CO, HC, NOx, PM and smoke. Okay. Similarly, as I said, this is the norm for generator more than 800 kilowatt, less than 800 kilowatt and this is for more than 800 kilowatt. Okay. So, this is the next norm for 2014. These are 2014 norms. These are just implemented, and this is for more than 800 kilowatt. So, these are the norms for more than 800 kilowatt. Basically, these kind of gensets are used for illuminating townships which are isolated from the grid. So, there are a lot of change in the fuels also. I will just give you one simple example of BS6 fuel compared to European fuel that is available. So, in Europe you have research octane number of 95, but BS6 says 91. Motor octane number is 85, motor octane number here is 81. Minimum olefin content here is 18, here it is 21% allowed. So, maximum olefin content. Maximum oxygen content allowed is 3.7, here it is 2.7. Distillation point 360, this is 370. Density is 845, here it is 820 to 860. And maximum pH content in the fuel is 8%, and here it is up to 11%. So, there are certain specifications that are out. Difference between BS4 and BS6 standards for the emission norms. Here you can see this is for the petrol norm BS 3 and 4 for CO, HC and NOx. But if you look at diesel 3, 4 and 6, you see here this is the carbon monoxide, not much change. NOx, there is quite a bit of change, 1/4. Okay. HC plus NOx about half, particulate there is hardly any change. Okay. This is also very important. Why is the industry is resisting? There is a lot of resistance in the automotive industry, and there is a lot of resistance in oil industry. And I doubt seriously, I mean, in my personal opinion, I doubt whether the government will be able to implement it on 2020 because of the resistance. Only 2.5 years, and I do not see anybody being ready as of now. So, there are two major industries which face the problem. First is the oil refinery, that will need to make substantial investment to upgrade the fuel specs. These upgrades will allow the refineries to supply the fuel type that can match the BS6 standards. Okay. Second is the automotive manufacturers, and automotive obviously they have to optimize the combustion, but more importantly they have to look at all kinds of after treatment systems. Okay. Skipping a stage like BS5 put extra pressure on the manufacturer. They thought that it will make it easy, but no, it will make it more difficult, because now you have to jump 2 steps. So, they have to produce the compliant vehicles. The shift in technology from BS4 to BS6 is likely to cost anything like between 50 to 80,000 crore to the petroleum companies alone, and OEMs it will be even more. So, it requires actually huge amount of investment, and this is just one picture which I promised to you in the beginning, that I will tell you what is the scenario in 2015 in the whole world. So, if you look at US, for example, in US this is mostly in Europe, this is US and this is Canada, everywhere it is US tier 2, very low emission standards. Okay. And here this is US tier 2 and Euro 5, which is under discussion in Mexico and other countries. Okay. It is still Euro 5. In the Europe it is Euro 6 everywhere. In the whole of Russia it is Euro 5. In India and China they basically Euro 5 in the mega cities, nationwide it is Euro 4. Latin America, this is also Euro 4 and 5 under discussion. If you look at Australia, Australia is Euro 5. If you look at Africa, well, these are the places where all the junk vehicles from the world go. Biggest market for used vehicles, obsolete vehicles. Go to any African countries, you will find a lot of Indian OEM vehicles plying on the road, putting the. There are some countries, although on the in the South African continent, which have Euro 3 or Euro 4.
What about these Middle Eastern countries?
You can see this scene here. Who cares? The population density is so low and the temperatures are so high. Whatever you emit, it goes into the environment in no time. Anyway, they are putting so much of fuel and their evaporative emissions etc. are so high, and the petrol is cheaper than water. So, nobody cares about any of these emissions, and so okay. So, this just shows the implementation. Here on the x axis you have the year, here there are different countries and transitions are shown. Same information how the countries have made the transition. So, this is India. You can see India is divided always into two, 13 cities and rest of the country. Really a dichotomy. US you see everywhere it is same one. Entire Europe 20 countries, they sing in one tune. Japan, Korea, Russia, China is our cousin, and Brazil. This is probably the last slide. It shows toxic emission standards on the passenger vehicle standards. So, this is Japan and Europe and US. It shows these are the years how it has implemented. So, EPA standard started, then tier 0 and US 87 came in picture, tier 194 came here. It was equivalent to Euro 3. In Japan these were the standards. So, it just shows that how the contemporary standards changed in Japan, Europe and US, because these are the lead countries actually which are showing the path to the rest of the world, how to make emission norms or how to develop the engine technology to meet those emission norms. So, as we know, what is fuel additive. So, fuel additive is any liquid that is added to a fuel which is either supplied to engine or vehicle, basically for doing a particular
with a particular objective. Okay. So, these are the compounds that are formulated. So, not naturally occurring, they are formulated to enhance the quality and efficiency of the fuel used in the automobiles. Okay. So, for example, the objective can be to increase the octane rating. Okay. We very well know that in former times before 1990s, there used to be tetraethyl lead that was added to increase the octane rating. Similarly, now there are more harmless additives that are added. There could be corrosion inhibitors. Okay. So, in fuel line, whatever components you have, if the corrosion should not take place. Okay. And basically, the additives to allow increase the octane rating, so that you can use higher compression ratios and you can get higher efficiency and power. And then this also helps avoid the problems of rough idling, weak acceleration, stumbling or stalling of the engine. So, to avoid this, there are many additives that are added. Then the other objective is that engine maintenance is a very, very serious issue. So, if somehow you can reduce the engine maintenance by adding some additives to the fuel, that will be great. So, engine maintenance can also be reduced by using additives. So, what they do is there are also some additives which are helpful in engine maintenance. Okay. They are effective in prolonging the life of the vehicle and the gap between the two services. Fuel additives are also claimed to enhance power, gasoline as well as for diesel. Diesel additives offer the function of antioxidant that helps you minimize the corrosion inside the engine, as well as anti-knock agents to ease the stress on the piston. So, the sludge. So, if there is any deposit on the cylinder walls, piston top, they tend to take care of it. They control the soot formation. They also improve the combustion inside the engine, and they act as biocide. What is in terms of their point of application, where they are applied? For example, there could be refinery product additives, distribution system additives, and then automotive performance enhancement additives. So, if we look at the refinery products, refinery additives, so we add antioxidant and stability improvement additives. Stability improvement, antioxidant, you all know that if there is any attack of oxygen on the fuel, the polymerization and oxidation happens. So, definitely you need to add some additives which can prevent the oxidation of fuel molecules. And then you should also be able to improve the, see, in Kanpur you probably do not need cold flow problems, because you hardly get temperatures below 0 degree centigrade. But if you look at regions, for example, Kashmir or higher reaches of Himalayas and Ladakh region, half of the time of the year the temperature is below 0, and fuel always have some traces of moisture. So, what will happen? The moisture or the water content in that will freeze. So, then if the ice formation will take place, and then all the capillaries, pipes, everywhere the choking may take place. So, therefore, it is important that the water should be maintained in liquid form. So, you add some additives because of which the water is maintained in liquid form, and these are called cold flow. Actually act as catalyst, and then they trigger different types of reactions. Okay. So, these additives actually deactivate the metals. Okay. Similarly, if you look at the distribution system products, so in the distribution system, how the distribution is done? Distribution is done through pipeline from long distances, refinery to all the distribution centers, and corrosion products can then creep into the fuel. So, there are corrosion inhibitors that are added. Okay. And then pipeline drag reducing agent. So, when the fluid flows through the pipeline, there is a lot of drag it creates. So, the additives for that. Anti-static additives, in the winter time you have a lot of charge. You must have seen static in the cloths as well. Suppose you have a polyester cloth, you experience the charge. Now, this charge, when you touch something, there is a spark, and this spark unfortunately is sufficient enough to ignite fuel air mixture. Okay. So, if that happens, there will be a catastrophe. So, in order to avoid this, anti-static additives are added to the fuel. Okay. Similarly, if you look at, there are many additives for performance of the automobiles. For example, I told you deposit control additives, lubricity additives. I told you that in the diesel engines particularly, you have your fuel pump and fuel injector, there is no special lubrication. Fuel itself is acting as a lubricant, right. So, lubricity additives actually provide the necessary lubrication for the fuel pump and fuel injector in case of a high pressure diesel engine, high pressure, high fuel injection pressure diesel engine. Friction modifiers, obviously they are to reduce the friction inside the engine. Anti-foam additives are extremely important, just like the same way as lubricating oils, because if the fuel undergoes foam formation, there will be huge exposure of oxygen. So, the oxidation will accelerate. So, you do not allow the foam formation in fuel. You must have seen petrol, diesel you buy, you never have foam formation. Okay. The foam formation, bubble formation is actually less than water, right. Corrosion inhibitors, obviously it prevents the corrosion in high temperature, high pressure conditions. Demulsifier or dehazers. Demulsifier means if there is water, so they separate the water out. Anti-valve seat recession additives, this is something to do with the valve recession, valve seat recession. So, you see there are oxygenated chemical compounds are also added as additives to the fuel. Okay. So, oxygen is a part of the chemical structure and these are usually referred as oxygenated fuels. So, you really want some amount of oxygen in the fuel. Why do you want? Because so that the formation of carbon monoxide and hydrocarbons can be reduced. Okay. Oxygenates are usually employed in gasoline additives to reduce the carbon monoxide and also the soot that is created during combustion. These oxygenated, commonly used oxygenators are either alcohols or ethers. Okay. So, methanol, ethanol, isopropyl alcohols, normal butanol and gasoline grade tertiary butanol GTBA. So, MUOH, ETOH, IPA, BUOH, GTBA. Fancy names are given, but ultimately there are alcohols 1, 2, 3, 4, 1, 2, 3, 4 carbon chain length, that is it. Okay. So, there is some oxygen present. So, when you add them, you are doing two things. One is that you are replacing the hydrocarbon or fossil energy with more bioenergy, most of them are bioproduced, and then you are also putting fuel, oxygen in the fuel, and therefore, you are going to emit lesser amount of carbon monoxide and hydrocarbon. Okay. Similarly, ethers, this is methyl tetrabutyl ether, MTB, very important anti-knock additive added to the gasoline. Then similarly, TEM, tertiary amyl methyl ether, tertiary hexyl methyl ether, theme, then ethyl tertiary butyl ether, ETBE, tertiary amyl ethyl ether, TAEE, and diisopropyl ether type. Okay. So, very frightening names, but these are all ethers. So, ethers means there is carbon to carbon bonding, in between them there will be one C double bond O group or O group actually between O group. So, if there are two methyl, one oxygen in between. So, there is no direct, at least one carbon chain will be broken with oxygen being in between them. Okay. So, these are the oxygenated additives. Similarly, there are antioxidants and stabilizer. So, they are used to terminate the oxidation reactions which take place during different weather conditions. And once the oxidation happens, what will happen is the hydrocarbons will create different organic substances and the degeneration of the hydrocarbons will take place, which will change the quality of fuel, properties of the fuel will change. So, these stabilizers are directly used or in combination to prevent various effects such as oxidation, chain cessation and uncontrolled recombination or cross-linking reactions which are that are caused by photooxidation. So, because of the effect of the sunlight, because of the environmental factors, high temperature conditions. Okay. So, many of these things happen on which you do not have any control. So, in order to seize these, you add some antioxidants which is BHT, 2,4-dimethyl 6 tertiary butyl phenol, 2,6-di. You do not need to remember this, but these are some of the chemicals that are used as fuel additives. Okay. Different companies use either one of them or combination of them for achieving the objectives. And this is a very, very big industry because every liter of gasoline or diesel that you buy, it will have some of this. You may not know about it. It may have some of it depending on what kind of environmental conditions are there in the localized region where the gasoline or diesel is sold. So, Even the concentration can vary from zone to zone. For example, Kashmir and Ladakh, there will be a different concentration. Kanpur, there may be different region. Jaisalmer, there may be a different concentration. Anti-knock agents. So, anti-knock agents are basically additives which are used for reducing the knocking. Okay. So, basically they increase fuel octane rating by raising its pressure and temperature at which the auto ignition takes place. Okay. So, TEL, tetraethyl lead, was used for a long time, but then around 1990 we discovered that lead goes into the ambient and then children inhale it, it enters their body, it affects the neurological development. So, there were a lot of babies who were born around 1990s and 1990 to 2000 which are mentally retarded in India. Okay, you must have seen around your families or neighborhood, lot of children were born, and that's because of the lead. Okay, it affects the neurological development. And after that, once the lead has been taken out, this problem has kind of reduced quite a bit. Okay. So, this causes actually brain damage, and particularly in the children, because children consume, it affects adults also, but it affects children more. The reason is that per unit body weight, children consume much higher amount of oxygen, much higher amount of air. So, they are actually inhaling higher dosage of whatever is there in the environment, and that is going to affect their brain development. Okay. So, then there is this MMT is another substance which is used as anti-knock. It is extremely poisonous, neurotoxic substance, and it is fatal if swallowed, inhaled, and it causes disease similar to Parkinson, called manganism. Okay. Ferrocene is used, which is also highly toxic, then toluene is used, isooctane is used, tryptane is used. So, these are some of the additives, and this is a billions and billions of dollars of industry. So, normally it is a vicious cycle. So, they come up with one additive, they earn a lot of cash over 10 years, and then some scientists like us figure out that this is bad. Okay, they say sorry, we will develop another thing. They push another thing in the market, and then again after 10 years, when there is sufficient concentration in the atmosphere, they come up with another formulation. Okay. Have you seen the movie Erin Brockovich? No? Please watch it and you will understand what I am talking about. Okay. It is a Sandra Bullock movie. Anyway. So, there are lead scavengers for leaded gasoline. So, lead scavengers do not allow lead to come out. So, these are TCP. Okay. This is also antivariate and extreme pressure additive, 1,2-diboromethane and 1,2-dichloromethane. Similarly, there are fuel dyes. Sometimes some companies like to give color to the fuel. Okay. So, there are different types of dyes in red, yellow and blue which are added for giving a particular color, so that you do not mix them with the other fuels. Okay. So, fuel additives in general, the ether and other flammable hydrocarbons have been used extensively as starting fluid for many difficult to start engines, especially the diesel engines. So, they very easily start because they have very high CTN number. Nitromethane or nitro, you must have seen nitro engines for bikes. So, therefore, high performance racing fuel, nitro bikes. And also nitromethane is used in small remote control cars also, it is nitromethane is used. Acetone is a vaporizing additive mainly used in methanol for racing fuel to improve the vaporization to start. Then butyl rubber, then picrate improves the combustion and increases the fuel mileage. Then I told you about the fuel line antifreeze. I think I have discussed. You add some additives which lower the temperature, freezing temperature for the water, and then it keeps them in liquid form. There are some additives which take this water along with them to the engine, and it is injected in the engine. In the engine, it is a hot environment, so they vaporize and come out. So, this is the function of fuel line additives. Then there are gasoline stabilizers. So, what happens is, there are some applications which are only seasonal. For example, boat. So, if you are a boat owner, you are not going to use boat all the time. Okay? You will just have the boat only during the summer time you will use it. For example, electric generators are also used only once in a while. Lawn mowers are also used once in a while. But when you fill the gasoline and they stay in the environment, in the room for example, or in the open, temperature is going up and down every day. So, some of the lighter fractions actually evaporate. Only the heavier fraction of the hydrocarbons remain in the tank. Okay. Lighter fraction somehow find its way to escape into the environment. So, then when you want to start, lighter fractions are not there. So, the engine will be hard to start. So, in order to avoid this, gasoline stabilizers are added. So, they prevent the evaporation of lighter fractions and they help the engine start quickly without much of a difficulty. Similarly, there are octane boosters. So, there are many octane boosters. I think I have already discussed this octane enhancer, octane booster with you. Similarly, there are one set of additives which are called fuel injector cleaner. Fuel is injected and fuel injector gets some deposits of carbon, okay, because they are working in hot high temperature environment. So, basically these additives actually keep the surfaces clean. Okay, they remove the heavy heavy carbon deposits from cylinder head, valves, pistons, and also the fuel injector, and make the engine run smoothly. Then there are upper cylinder lubricants for the top part. This is not very important. This is mostly for the older engines. Then there is diesel exhaust fluid. Yeah. Diesel exhaust fluid isn't really a fuel additive. It's important to understand how it is used. Diesel exhaust fluid is metered from a separate tank of the vehicle directly into the diesel exhaust stream, where it breaks down into nitrogen, into NOx, into its basic components of nitrogen and water. If the driver, basically it's like a urea solution, okay, that's called diesel exhaust fluid. Its function is that when you inject the fuel, the urea solution into the exhaust system, it breaks into ammonia and carbon dioxide, and this ammonia reacts with the NOx that is present in the exhaust and converts it back into nitrogen and water. I'll talk more about it today itself. Then there are anti-gelling agents. Anti-gelling agents are added to the fuel tank to liquefy the solidified paraffin wax or gel that forms in the fuel and and clogs the diesel filters during sub-freezing temperatures. So, when the temperatures go down quite a bit, what happens is that some of the lighter hydrocarbons present in the diesel, they start getting solidified, but then most of the other things remain in liquid. So, a gel formation starts. Now, this function of anti-gelling additives to stop the formation of gel, because once the gel formation starts, the fuel viscosity will also increase. Okay, so that is avoided by anti-gelling additives.